Hi there, I'm Paul McKay and I'm going to go through AQA's A-Level Maths Paper 2 from the June/November 2020 series. So let's get straight into it. Okay, so question 1, we need to determine which of these functions is decreasing for all real values of x. So the first function is just e to the x, which is something that everybody should hopefully be familiar with anyway. And then the other three functions are transformations of the e to the x graph. So e to the x is increasing, so it's not that one. The second one, look at the coefficient in front of the x part. It's a minus sign. So that will cause it to decrease. But this minus sign in front of the whole function will cause a decrease as well. So the overall effect is that that will be increasing overall. In the third option, the coefficient of x is just 1, so that will cause an increase, and the coefficient in front is a minus sign, so that will cause a decrease. So overall, this function is decreasing, and that's the one that we want then. Question 2, which of the following equations has no real solutions? Okay, well, cot x is cos theta over sine theta. So that is equal to 0 if cos theta is equal to 0. And we know that that has zeros at 90, 270 and so on. ln x equals 1. Well, if we exponentiate that both sides, we get x is equal to e to the 0. So we know x equals 1 is a solution of that. So that's fine. Mod x plus 1 equals 0. Well, if we want the modulus of something to be equal to 0, then what's inside the bracket must be 0. So that gives us x plus 1 is 0. So x equals minus 1. So that has a real solution. The only one that doesn't then is this last one, sec x. And we know that sec is 1 over cos. And so therefore, if that was equal to 0, we'd have to have 1 over cos x equals 0. And if we try to rearrange that, we'd get something like cos x equals 1 over 0, which is undefined. So this is the correct option. Okay, question 3 is all about binomial expansions. And we need to be able to recall the general formula here. So a plus b to the power of n is n choose 0, a to the n, and then b to the 0. And then the number on the bottom of the choose symbol goes up by 1 every time. The power of a goes down by 1, and the power of b goes up by 1, and so on until we get to the last term, which will be n choose n, a to the power of 0, b to the power of n. So in this case, a is 2x and b is minus 3x. So if we try to apply this formula, we're not going to do the whole thing, but let's just look at the first few terms. So n choose 0 is always 1. So we just get 2x to the power of 8. That's the first term. Because minus 3 over 8 to the power of 0 is just going to be 1. Then we get 8 times 2x to the power of 7 times minus 3 over x to the power of 1, and so on. So if we just evaluate these first few terms to get a feel for it, so this first one is going to be, well, I'll not put equals, but this is going to have x to the 8 in it. The next one is going to have x to the 7 divided by x, so that's x to the 6. The next term after that is going to have x to the 4, and the one after that is going to have x to the power of 2, which is the one we want. So we need the fourth term. So if we keep going up the pattern, following the pattern, we're going to have 2x, so that's going to come down by another 2, so that's going to be 2x to the power of 5. The minus 3 over x part, the power of that will have gone up by 2, so that will be now 3. And the coefficient in front will be 8 choose 3. So if we evaluate all that, 8 choose 3 is 56. 2 to the power of 5 is 32. So 32x to 5. And minus 3 cubed is minus 27. Okay, so the x to the 5 over x cubed gives us the x squared that we were hoping for, and the rest of it is minus 48,384. Okay, so this is the coefficient that we want. Right, question 4, small angle approximations. So let's write these down. So tan theta is approximately equal to theta, and cos theta is approximately equal to 1 minus theta squared over 2. So if we apply this, these come from the first terms in the Maclaurin expansions of these. But if we now substitute these in, so we're going to have x and then tan 5x, so that's approximately equal to 5x. Okay, so this is approximately equal to that. Cos 4x we can replace by 1 minus 4x squared over 2 using the approximation, and then minus 1. So we need to just tidy that up. So on the top I've got 5x squared. On the bottom you can see that the 1's cancel, and I'm going to have 4x all squared, so that's 16x squared over 2. So that's 8x squared, and it's minus as well. So minus 8x. And the x squareds cancel, so we're just left with minus 5 over 8. Question 5, integration by substitution. So what substitution should we use here? Well, usually the simplest thing to do is just look at the inner function on the part where there's a function of a function. So that will be my u, the 4x plus 1. And what we always do when we do an integration by substitution is we also need to change the variable of integration, which we always do by differentiating the substitution. So that's equal to 4. Now if you treat this like a fraction, you can rearrange this to say dx is equal to du over 4. We also need to change the limits, because remember the limits mean x equals minus a quarter and x equals 6. So we need to use the substitution to change those. So if x is equal to minus a quarter, I've got 4 times minus a quarter plus 1, which is 0. And 4 times 6 plus 1 equals 25. If we substitute all those in, we've got 0, 25. I'll leave a little bit of space. I've got square root of u. But I've also got this x, which hasn't, sorry, so du, should be du there. And then divided by 4. So replacing the dx by du over 4. But I've also got this x, which hasn't cancelled out. So what I need to also do is rearrange this substitution for x. So I get a quarter of u minus 1. So the two factors of a quarter, let's just put those outside and write 1 over 16 outside the integral. And then I've just got u minus 1 times the square root of u. So u times square root of u gives u to the power of 3 over 2. And then minus 1 times root u, so I'll write that as minus u to the half. So if we perform those integrals now, we just need to increase the power by 1 and then divide by the new power. So the first term, the power becomes 5 over 2, and then if we divide by 5 over 2, that's the same as multiplying by 2 over 5. And then similarly with the second term, I'm going to get minus 2 over 3 u to the 3 over 2. And if we substitute in the values, we're going to get 625 over 8 minus 125 over 24, which gives an answer of 875 over 12. Okay, so this equation that's given in question 6 is the equation of a line which is tangent to a circle. So let's draw a little picture to help us out. So the circle is centered at 7 and 9. And this point here that we're trying to find, let's call that just x and y. And we also know the equation of this tangent. Let's rearrange that into the form y equals mx plus c. So first of all, we move the 12x to the other side, becomes minus 12x. And then divide by the 5. So we'll need that equation in a bit. What we can also say is that we can work out the gradient of that normal line, because we know that the gradient of the normal times the gradient of the tangent is equal to minus 1. So the gradient of the normal is minus 1 over the gradient of the tangent. And because I've written the equation of the line in the form y equals mx plus c, we know that the tangent then has a gradient of minus 12 over 5. So that tells us that the gradient of the normal will be, if we divide by a fraction, we find the reciprocal and multiply, and the minus signs cancel, so we get 5 over 12. But we also know that the gradient of the normal line is just delta y over delta x. So we're looking at the point of intersection in the center of the circle. Delta y is going to be y minus 9, and delta x is going to be x minus 7. So that gives, so if we rearrange that part, so cross multiply, we get 12y minus 108 is equal to 5x minus 35. And we can rearrange that to give minus y equals minus y equals 5 over 12x plus 73 over 12. And then we just have to rearrange, then we just have to solve these two equations simultaneously. So I'll call this the equation of the tangent number 1 and the equation of the that we just found number 2. So if I do 1 minus 2, then the y terms cancel out. So I'm just doing one equation minus the other equation. So I get 0 from y minus y. I get minus 12x over 5 minus 5 over 12x. And then I've got plus 298 over 5 minus 73 over 12. Okay, put things over common factors, and you get minus 169 over 60x plus 3211 over 60. And if you solve that, you get x is equal to 19. Then substitute it back into one of the equations. So let's go back into the tangent equation. So minus 12 times 19 over 5 plus 298 over 5. And if you work that out, you get 14. Okay, so the point of intersection is x equals 19, y equals 14. Okay, part B, find the equation of C. Okay, this bit's a little bit easier now. So we know what the point x and y is. So let's just draw another picture here. So this, we know this point now is 19 and 14, and that the center of the circle is 7 and 9. So that allows us, the distance between those is going to be the radius of the circle. But we can just substitute in the x values. So we've got x, we know the equation of the circle is going to be x minus 7 squared plus y minus 9 squared equals r squared. So if we substitute in x equals 19, which is on the circle, and 14, which is on the circle, then that will give us r squared, so just Pythagoras there. And that is, so we've got 12 squared plus 5 squared, which is 169. So that's what r squared is equal to. So therefore the equation of the circle is x minus 7 squared plus y minus 9 squared is equal to 169. 13 squared. Okay, question 7. A proof now. So a and b are two positive irrational numbers. The sum of a and b and the product of a and b are both rational. And first of all, we need to identify a mistake in this proof. And the mistake here is in this line here. Okay, you can't do that with fractions. You can't just add the numerators and add the denominators together. Okay, so incorrect. The mistake is incorrect addition of fractions. Okay, write down a correct version. So the correct version should be, if we add those together, we put them over a common denominator of AB, and then we're going to get B plus A. And we're told in the question that since A plus B and AB are rational, then 1 over the other is also rational. Okay, and then that's the proof that's expected. 7b, prove by contradiction that the difference of any rational number and any irrational number is irrational. Okay, so the difference of a rational number, so let's write, so a over b, that's rational as long as, well, we'll write down what those terms mean in a bit, minus x is equal to some other rational number. Okay, so we're assuming that a, b, c, d are integers and x is an irrational number. Okay, so if a, b, c, d are integers, then a over b and c over d are rational fractions. So this is the contradiction method. We assume the opposite of what's in the question. Okay, so the question says prove that the difference is irrational. So where we start by assuming that it's not irrational, that it is rational instead, and see where that leads us. So if we rearrange for x, we get x is equal to a over b minus c over d. And again, put things over a common denominator, so we get AD minus BC divided by BD. And if A, B, C, D are all integers, then that is rational. So we've proven that x must be rational, but we've claimed that it's irrational, therefore contradiction. Therefore, the difference must be irrational instead. Question 8 is about parametric equations. So first of all, find a Cartesian equation of the curve in the form y squared equals f of x. So the typical way people are usually taught is just to rearrange one of these equations for t and substitute into the other one. Okay, so you could do it like that. That's fairly straightforward. But even easier here is we want it in the form y squared equals f of x. So let's just take y and square it. So y squared will be equal to 2t squared, which is 4t squared. And t squared there, that's just x. So that's equal to 4x. That's it. So y squared is 4x. Okay, so this time we've got a few more things added to the diagram. We've got some tangent, which intersects the curve at A. And that tangent lies at an angle theta compared to the horizontal. So the first question says, consider the gradient of the curve and show that tan theta equals 1 over A. Okay, so If we think about, let's just form this into a triangle here. We know that tan theta, going back to the very simplest trigonometry, is opposite over adjacent. But that is just if we extend all this all the way down to the axis. Okay, think about a similar triangle. That's just delta y over delta x, which is the gradient. So we can see that tan theta is equal to the gradient of the line. So I'll write dy by dx instead. And we know for parametric equations that dy by dx can be worked out by dy by dt over dx by dt. Y was 2t, so the derivative of that is 2, and x was t squared, so the derivative of t squared is 2t, so that gives 1 over t. And at this point A, we're also told that t is equal to A. So therefore, at A, tan theta is equal to 1 over A. Here, B part 2, find tan phi, so this other angle, in terms of A. Well, let's apply the same logic. We know that it's delta y over delta x, and in this case we can just work that out. So the change in y is going to be the value of y at A, and the value of y at A comes from substituting in t equals A into the function. So at A, x is equal to t squared, so that's going to be A squared, and y is equal to 2t, so that's 2 times A. So we've just substituted in the value of t at that point. And we know the value of B, we're told that has coordinates x equals 1, y equals 0, so we've just got to put that together. So tan phi, which is equal to delta y over delta x, equal to the gradient, is 2a minus 0 divided by a squared minus 1. So just get rid of that 0, and there we are. There's tan phi in terms of A. The last part, show that tan 2 theta is equal to tan phi. Well, tan 2 theta, we should be now thinking double angle formula. So tan 2 theta is equal to 2 tan theta divided by 1 minus tan squared theta. We know that tan theta on top, well, we know that tan theta is equal to 1 over A, so we've got 2 times 1 over A, and on the bottom 1 minus 1 over A squared. And if we multiply top and bottom by A squared, then we get 2A divided by A squared minus 1, which is exactly what we had up there, so that's equal to tan phi. Right, question 9 is an optimization problem. So a cylinder is cut out of a hemisphere, and we want ultimately to find the biggest cylinder that we can cut out of it. So big R is the radius of the
hemisphere. H is the height of the cylinder, and we want to find the volume of the cylinder. Well, first of all, we know that the volume of the cylinder, let's add a small r for the radius of that cylinder. We know that V is equal to pi r squared times h. But look at the radius of the hemisphere. If we move that line around here, we can also see that the value from there to there must also be big R, okay, because that's also the radius of the hemisphere. And then we can just use Pythagoras to find R. So we know that r squared is equal to small r squared plus h squared. And we want this value, so we'll just rearrange this like so. So our volume is pi times r squared minus h squared times h. And if you multiply that out, you get the expression that's given. Part B is find the maximum volume then and justify your answer. So first of all, let's just write down what we had from the previous page. So we had pi r squared h minus pi h cubed. So r is just some constant for the hemisphere. H is the only variable here for the cylinder. So we can differentiate that. So dv by dh. So the first term is just linear because pi r squared is a constant. So when we differentiate that, the h will just become 1. And then the second term, h cubed, becomes 3h squared. So I've got 3 pi h squared. And we know for a maximum or minimum value that this must be equal to 0. So we just need to solve that. You can see that the pi's cancel out. So we get r squared is equal to 3h squared. And dividing by 3 and taking the root, we're going to get h is equal to r over root 3. So if we then substitute that back into the volume formula, and simplify everything, so the first term is going to be pi r cubed times 1 over root 3. And then the second term also has a pi r cubed, and then we've got a factor of minus 1 over root 3 cubed. So that's going to give minus 1 over 3 root 3. And if we look at it like this, we can also take out a factor of 1 over root 3 then. So we can take that outside, and then I've got inside 1 minus a third. Okay, so I've got 1 over root 3 minus a third 1 over root 3. So I can do that factorization. And then 1 minus a third is 2/3. So I've got pi r cubed times 2/3, and then divided by root 3 as well. So I can say that that is the answer there. And the last bit is to justify your answer. Okay, so how do we know it's a maximum volume, not a minimum or a point of inflection or something? How do we know it's a maximum? Well, second derivative. So if we just differentiate again, so d2v by dh squared, then the pi r squared, so we're taking this expression, so the pi r squared term will vanish, and then the second term, we're going to get another 2 coming to the front, so we'll get minus 6 pi h. Okay, so h is greater than 0. Okay, it has to be. The height of a cylinder can't be a negative number. So therefore, because we're multiplying that by minus 6 pi, that must be less than 0. So therefore, it's a maximum. Right, on to some mechanics now, second half of the paper. So we've got a vehicle driven at a constant speed of 12 meters per second along a straight horizontal road. Which of these statements below is correct? Well, if it's at a constant speed, then that means that the acceleration is 0. And because F equals ma, that tells us that the overall force must be 0. So the resultant force acting on the vehicle is 0. That's what we want. Next one is just combining vectors. So that a number of forces acting on a particle such that the resultant force is 6 in the x direction, minus 3 in the y direction. One of the forces acting is 8 and minus 5. Calculate the total of all the other forces. Okay, so this one, So let's say the other forces, let's call it Fx and Fy. It's going to be equal to 6 and minus 3, and then minus 8 minus 5. So subtract the x part. 6 minus 8 is minus 2, and minus 3 minus minus 5, minus 3 plus 5 is 2. So the correct answer is the third one there. Question 12. Some more work with vectors, now written in the I, J, K sort of form. So we're told that there's two particles. One moves with a velocity 8i minus 12j. The second one, ai plus 9j. And they are moving parallel with each other. So what that means is that ai plus 9j must be equal to some constant times the first one. So I'll call it lambda. So that's just a question of ratios really. So let's look at the y part. If we look at the y terms, we've got 9 is equal to minus 12 lambda. So lambda is equal to 9 over minus 12, which is the same as minus 3 over 4. So if we look at the x parts, we've got a is equal to 8 lambda. So 8 times minus 3 over 4, minus 24 over 4, that's minus 6. Okay, a statics problem next with a balanced beam. So a uniform rod, 7 meters long, mass 4 kilograms. The rod rests on this pivot. The pivot is 2 meters away from one end where a weight is attached. Okay, so what can we do? Find the weight. Find this weight W here. Well, let's put on the mass of the beam. So the mass of the beam, because it is uniform, it acts at the center. So 3.5 meters along here. 7 over 2, 3.5. And the mass of that, the weight of that is 4 kilograms times g. Okay, so there's the weight there. And we know from the principle of moments that the sum of the clockwise moments acting around the pivot must be equal to the sum of the anti-clockwise pivots. So what we need to know is the distance of the weight of the rod from the pivot. So this must be 3.5 minus 2, which is 1.5 meters. So we can say 1.5 times 4g clockwise must be equal to 2 meters times w anti-clockwise. So w is equal to 1.5 times 4g over 2, which is 3g. Explain how we've used the fact that the rod is uniform. Well, if it's uniform, then that's allowed us to place the weight at the center of the rod. Right, next we've got a position vector for a particle, and we want to find the speed of the particle. So the first thing we can do is we can find the velocity of the particle by differentiating. So differentiate that expression, we get 3t squared minus 10t in the I direction, and then 8 minus 2t in the j direction. So just differentiating each component. So this is the velocity, but we want the speed, and we want the speed at t equals 2. So the next thing we could do is we could work out the velocity when t equals 2. So just substituting t equals 2 into there. So we've got 3 times t squared, which is 12, minus 20,
So 12 minus 20 is minus 8, so we get minus 8i. And then substituting into the other component, I get 4j. So we're almost there. We've got the velocity when t equals 2. The last bit is to find v, and that's just the magnitude of that function, which we find by Pythagoras. So it's minus 8 squared plus 4 squared. So square root of 64 plus 16, which is the root 80. Okay, so that's the answer. If you want to, you put the units on as well, meters per second. Bella claims that the magnitude of acceleration of p will never be 0. Determine whether Bella's claim is correct. Well, let's find out the acceleration. So take my velocity vector that I had before, differentiate it once more. So I'm going to get 6t minus 10 in the I direction plus minus 2 in the j direction. Okay, so just need to sort of explain this now. So it will always have a j component, therefore never 0. Therefore Bella is wrong. Okay, so quite an easy calculation for 3 marks, but you've got to make sure you've explained how that leads to Bella being wrong. Right, so we've got a graph now of a moving particle, and we need to use the trapezium rule with 4 strips to estimate the distance between t equals 20 seconds and t equals 100 seconds. Okay, so if we follow up from 20, let's go all the way up there. This is where it would actually be easier to do by hand than on a computer. But we get roughly, let's say that this is about 130, sort of halfway in between. We want 4 strips, so that means that we need to space it out, that each strip must be 100 minus 20 over 4 wide, so that's 20 wide. So we go up in multiples of 20. So if I draw these other points on, like so, because we'll need the values of these. So if we follow this along, we get 80. If we follow that line along, we get 120. If we follow that line along, we get about 140. Okay, there's this sort of question is always a bit of leeway in your final answer, but not much. So you can't be claiming that these numbers are wildly different from what you read off the graph. So use the trapezium rule. So the trapezium rule tells us that the area is equal to a half of h. So h is the width of each interval, so that's 20. And then the trapezium rule is the first term, which is 130, plus the last term, which is 0. So when t is 100, v is 0, and then plus twice all the other ordinates. So we get 140 plus 120 plus 80. And so that's 10 in front, and inside of here, 140 plus 120 plus 80, that's 340 times 2 is 680, plus 130 is 810. Okay, and obviously just do that in your calculator. So that's 8,100 meters. Okay, about 8.1 kilometers. Question B just says, over the same time period, you could model it with a quadratic. What other estimate could you use if you had a quadratic instead? And the idea is you would just integrate the quadratic from t equals 20 to t equals 100. That's all you need to say. Okay, so in this question, we've got two particles dropping onto a surface, and A is released from a height of h meters, B is released t seconds after A drops from a different height, and both particles land on the surface 5 seconds after A was first released. A little timeline of what happened might be useful here. Okay, so first of all, A is released, then t seconds later, B is released, and then at some later time, A and B hit the ground. And we're told that they both hit the ground 5 seconds after A was first released. So this time here is 5 seconds. So that must mean the time it takes for B to hit the ground after being released must be 5 minus t. So we're going to use an equation of motion now, and the one that we always seem to end up using in most problems is this: s equals ut plus a half at squared. And in fact, in this case, both are released from rest. So that means u equals 0. So s is equal just to half at squared. So let's apply that formula to both particles. So particle A drops from a height of h, so s equals h, and the time it takes is 5 seconds to hit the ground. So we've got h is equal to 25 over 2a. For B, it drops from a height kh, and it takes 5 minus t seconds to hit the ground. So we're going to get 5 minus t all squared. Now what we need to do is we need to eliminate h from these equations. And the easiest thing to do is just substitute h into the second equation. So we've got k times 25 over 2a is equal to a half a 5 minus t squared. So I've just substituted 25 over 2a for h into the second equation. And then after that, it's just a case of rearranging for t. So what can we do first? Well, we could cancel out a 2 on both sides. Okay, cancel out the halves, cancel out the a's as well. They will disappear. So I've got 25k. So take the square root of both sides. So I'm going to get plus or minus root 25k is equal to 5 minus t. Root 25k is the same as plus or minus 5 root k. So root 25 is 5. And therefore t is going to be equal to 5 minus or plus root 5 root k, which is 5 times 1 minus or plus root k. Okay, last bit though, and so we're not quite done. We know that from our diagram we draw before that t must be less than 5. Okay, t can't be greater than 5, so that means that we must take the minus sign. So it must just be 5, 1 minus root k. Question 17. We've got a ball projected off a surface. We're told that the ball needs to land d meters away. So that's the range of the projectile. So let's just draw a little diagram again. So it's being projected at a speed u, and it's landing some distance d away. And this angle here is theta. So let's use that same equation of motion again, s equals ut plus a half at squared. And let's solve it in both directions. So vertically, the particle lands at the same, it's a horizontal surface, so it lands at the same height as it started. So that means that the displacement vertically is 0 overall. The initial velocity is going to be u times sine theta. So I'm taking upwards as the positive direction here.
the acceleration is going to be down. Okay, gravity acts down towards the centre of the Earth, so minus a half g times t squared. Oh, I've missed a t off from the first term as well. So u sine theta t minus a half gt squared. And that, if we factorize that, we can say t, take a factor of t, so we've got u sine theta minus a half gt. So this has two solutions, either t is equal to 0, which is at the start, obviously, or t is equal to 2u sine theta over g. Okay, and that must be at the other end. Let's resolve this horizontally as well. So horizontally, the distance travelled we're calling d, and the horizontal initial velocity is u cos theta, then times t, and horizontally there's no acceleration because we're ignoring air resistance. So all we need to do is, if we substitute our expression we found for t into here, we're going to get u cos theta multiplied by 2u sine theta over g. Put the u squareds at the front, so I've got u squared over g, and then I've got, so I've left the two separate just so I can write it like this: 2 sine theta cos theta, because we hopefully recognize this as being equal to sine 2 theta. Okay. What we should have had at the start is not equals, so d is less than or equal to. Okay, because it was, the particle needs to be at least d meters away. So if we rearrange that, so multiply by g, divide by u squared, then that's going to give us sine 2 theta is greater than or equal to dg over u squared, which is what we're after. Okay, so this question, we've got a block A resting on a rough plane, so that means there's going to be a coefficient of friction to deal with. It's attached by a string over a pulley, and then there's another particle B, 2 kilograms, at the other side, and we're told when it releases from rest, B starts to move downwards. So it's going to have an acceleration acting down, and that means that A, because it's an inextensible string, must have the same acceleration moving up the slope. We're told that the plane is inclined at an angle such that tan theta equals 7 over 24. Okay, let's just make this into a triangle. So we know that from the very simplest trigonometry that tan theta is opposite over adjacent. So we know that it's as if the slope rises up 7 and runs along 24. And if we use that to find the hypotenuse, then we find that the hypotenuse is 7 squared plus 24 squared rooted, and then so that gives 25. So therefore we can write down sine theta opposite over hypotenuse, so that's 7 over 25, and cos theta is 24 over 25 opposite over adjacent over hypotenuse. So those will become useful for us later. What we should do is then draw a free body diagram for A and for B. Let's think about the forces on each of those. So A, first of all, so it's got its weight acting down, so that's 0.2 g. But what I want to do is I want to split that up into two components. I want to split it up into a component acting into the plane. So what we need to identify with these problems of things on planes is that the angle of the slope is also equal to the angle in here. So that's going to be 0.2 g, the weight, multiplied by the cosine of the angle, which was 24 over 25. Acting down the slope, we've got 0.2 g times the sine of the angle, which is 7 over 25.
Okay, we also know that acting out of the plane, we must have an equal and opposite force, because the block is not moving into the plane or moving away from the plane, so they must be balanced. So the normal force is equal to 0.2 g 24/25 also. The particle is being pulled up the slope by some tension in the string. We'll just call that T, we don't know what that is yet. And because it's being pulled up the slope, it must have a frictional force acting in opposition to that. And we know that the frictional force is equal to the coefficient of friction, which we need to find in part A, multiplied by the normal force. So we'll just leave it like that for now, so it doesn't get too complicated. Let's do the same sort of analysis for B. So B is a lot easier. We've got two forces acting on B. We've got the tension up in the string, and we've got the weight of B acting down, which is 2g. Okay. So what we're going to do now is we're going to use Newton's second law. So the sum of the forces acting on the particle is equal to the mass times the acceleration. So it's accelerating down. It has a mass of 2, and the acceleration we're given in the question is 543/625g. And because we're thinking about accelerating down, let's consider the forces down first. So that's 2g acting down minus any in the opposite direction, so the tension acting up. So 2g minus t. And therefore we can rearrange that for t. And that's going to give us 2g minus 2 times 543/625g. We'll just leave it like that for now. We'll not work it out yet. Let's do the same analysis for A. So it's accelerating up the slope. So let's think about the force up the slope first, which was the tension. So we've got the tension minus the frictional force minus the component of the weight acting parallel with the slope, which is 0.2g times 7/25. And that's equal to the mass of A, 0.2, times the acceleration of A, 543/625g. Okay, let's substitute in for t and for f. So t is 2g minus 2 times 543/625g. Okay, we got that from analysing particle B. We know that f is mu times n, and n is, if we go to the diagram, 0.2g times 24/25. So we've got mu times 0.2g 24/25. Okay, so that's f. And then minus that component of weight is equal to 0.2 times 543/625g. And from there, it's just a case of rearranging everything to find mu. So you'll find mu is equal to, if you put all of that into your calculator, so cancel out the g's first, and then put it on your calculator, and you'll find mu is 17/100, okay, or 0.17, which is what we're asked to find. So quite a long question there, but we got there in the end. Part B. So we're told that when A reaches a speed of 0.5 meters per second, the string breaks. Find the distance traveled by A after the string breaks until come to rest. So if you imagine it, the particle, the block is going up the slope, then it snaps, and its momentum allows it to carry a little bit further up the slope before coming to a stop. So up the slope, we've got that the initial speed is 0.5 meters per second. We've got the acceleration is equal to the sum of the forces acting. So that's going to be Well, we'll just write sum of the forces divided by the mass, first of all. So what have we got acting now? Well, we don't have the tension anymore. So the only forces acting are the forces which are acting down the slope, which was the component of the weight, so 0.2 g times 7 over 25, and then the frictional force, so 0.17 times 0.2 g times 24 over 25, and divided by the mass of A, which is 0.2. So if you put all that together, you get approximately for A minus 4.3478 meters per second squared. Now we're going to use an equation of motion to find the distance travelled. We know it comes to rest at the end, so we know that v is going to be equal to 0. And we're trying to find s. So which equation involves u, a, v, and s? Well, it's this one. If we rearrange that for s with v equals 0 in, we get s is equal to minus u squared over 2a. So we get minus 0.5 squared divided by 2 times minus 4.3478. And if you work that out, you get about 0.0288 meters. B part 2, state an assumption that could affect the validity of your answer in the first part. Well, there are a few things that we've assumed in this problem. Okay, so we've assumed there's no air resistance in the problem itself. Okay, if there was air resistance, it wouldn't, well, it would definitely affect that. We assume that the particle reaches, before it comes to rest, it hasn't hit the particle. Sorry, that it doesn't hit the pulley. The particle doesn't hit the pulley. What else could we assume? That we have assumed that the string doesn't go underneath the block. Okay, obviously if the string snaps, you can imagine a real situation. The string could just lie on the plane and get in the way of the block moving up the slope. So there's a few things that we assume there. Okay, so just one of those would do. Okay, last question then. So we've got an equation for the acceleration of a particle in terms of its velocity, and we need to form a differential equation to find an equation for v in terms of the time. So we know that the acceleration is equal to dv by dt, and the acceleration that we're given is 0.1 v squared. So we use separation of variables, so bring all the v terms to the left hand side. So we've got 1 over v squared dv, and we'll move the dt to the right, and then we'll integrate both sides. So that's going to give us, we'll move to the left here, minus 1 over v is equal to minus 0.1 times t, and then plus c. Then we'll use this initial condition. So the initial velocity, so that means when t is equal to 0, v is equal to 4. So we've got minus 1 over 4 is equal to c. So therefore, minus 1 over v equals minus 0.1 t minus 1 over 4. Or in other words, 1 over v is equal to 0.1 t plus 1 over 4. And then we just got to rearrange this for v. So let's just take reciprocals of both sides. So we get v is equal to 1 over 0.1 t plus 1 over 4. And then if we just multiply top and bottom by 20, then we get 20 on top, and then on the bottom we get 2t plus 5, which is what we were expected to find. 19b, find the acceleration of the particle when t is 5.5. Okay, so nice simple one to finish off. So acceleration
is minus 0.1 times v. So we've got that squared. So just substitute in t equals 5.5. So we've got minus 0.1 times v squared. So 0.1, 20 divided by 2 times 5.5. So that's 11 plus 5 squared. And if you calculate that, you get minus 5 over 32 meters per second squared. Okay, and that's the end of the paper. If you found that useful, please like and subscribe. And if you want any more help with any maths or physics, you can visit my website, www.physicsmathstuition.com, and I can see if I can help you out with that. Okay, bye for now, everybody.